righty?
Greg says he loves your costume.
Oh, good, good. That's the problem with being old, is that no one understands your costumes. Old man Whitmire.
Yeah, she's nice, but she teaches like merit classes, so like the students aren't nice.
Oh, I hate that.
I think I'm an algebra 2 merit. I think it's next semester.
So I was in. I don't know she teaches that, but
That's
so
not
like the
like
merit class was fun because like I'd never been to a merit class before, but like she gets really pissed off that like if you're nicer, she'll be nice to you.
All right.
encouraging.
So, let's talk about solving logarithmic equations. All right, which we kind of already did for the warm-up. So anyway, put the cart before the horse in that case, but that happens sometimes. All right, so to solve a logarithmic equation, all right, the first thing you want to do is just kind of isolate the logarithm, because that's where your variable is, right? So in the same sense as all the other equations you've ever solved in your life, right, wherever that variable is, you want to get the variable kind of by itself, or as close to by itself as you can, okay? I'm going to write out a few steps here just for help, but a previous step to this, one that we don't have to follow in this particular equation, but something that will be helpful later. If you have multiple logarithms, combine those multiple logarithms. I'm just going to abbreviate that with logs. Combine multiple logs into a single log. Okay, and again, we'll put that on both sides, because again, you may have logarithms on both sides. Okay, so combine multiple logarithms into a single log on both sides. Of course, you can also, move all the logarithms to one side and then put them all together too. That's a choice as well. I'll get you your quiz later. Okay, I'll show you that. All right, and like I said, once you did that, then you're going to isolate the log. Okay, get it by itself. And then, well, this is kind of hard to verbalize, but it's easier to just show, but I'm still going to write it out because, you know, for completion's sake here. So once you've isolated the log, in fact, maybe we'll go through the step here to that point. So let me get to that point. So let's isolate the log here. So what would be our first step in order to isolate this logarithm? What should we do? Yeah, subtract 5 from both sides, right? So 2 natural log x equals -1. And then what will be the next good step to get that log by itself? What's still with the natural log that we need to get rid of? The 2, right? Divide both sides by 2. Okay, we could make that 2 the exponent of x. That is an option. I see what you're saying there now. Okay, yeah, we could do that. Or we could just do this too. Divide both sides by 2. Okay, now to eliminate the natural log, because I'm not interested in what the natural log of x is, I want to know what just plain old x is. Okay, so one way to eliminate the natural log here is to raise both sides, okay, to a power of the log's base. This is really weird. Okay, or if you want to think about it another way, rewrite in exponential form. Okay, especially in this case, it's easy because we just have one logarithm. So alternatively, you can think about it as rewriting it in exponential form. Okay, so let me kind of try to describe here what I mean by this raise both sides to a power of the log's base. So what we're going to do, it's kind of what Ethan was describing from the warm-up if you were following along with him, but the idea is, all right, when you have a logarithm, right, what's the base of this logarithm? E, right? Okay, and so just like we use natural log to kind of cancel out E, we're going to use E to cancel out the natural log. Okay, we'll use the base to cancel out the log. And so when I say raise both sides, so we're going to take this natural log of x, we're going to make it an exponent, and we'll do e to the natural log of x. And then on the right-hand side, we'll do the same thing. We'll do e to the -1/2. Okay. E to the natural log of x is simply x. So they cancel each other out. All right. And then e to the -1/2 is e to the -1/2. And that's our answer. X is e to the -1/2. or if you like, 1 over e to the positive 1/2, or if you like, 1 over the square root of e. Any of those would be fine answers there. Okay. Although typically we don't end with a negative exponent, right? But you get the idea. Okay. The last step we should really do here is check for extraneous solutions. Okay. Remember that a logarithm, right, has a limited domain, right? When you take the log of something, the domain is limited, right? Can we take a log of 0, for example? No. Can we take a log of a negative number, for example? No. Okay. Both of those things don't exist. Okay. And again, I can explain why if you're still uncertain about that. But the idea is here. So basically, you want to make sure you're not plugging in, kind of negative numbers into your logarithms, or you don't end up with evaluating negative numbers. With 1 over the square root of e, that's fine, right? No problems there. So, and it would check out if you typed it back in. All right. So let's try another one here. Any questions on that process so far? All right. We'll do 2 more here together, and then I'll have you guys try one. All right. So example. So let's do one now with multiple logarithms. Oh, 2 ln x. Okay, so we'll say natural log of x minus 2 plus natural log of 2x minus 3 equals twice the natural log of x. Okay, so we have multiple logarithms here, do we not? They do have the same base, so that's key, right? Because otherwise we wouldn't be able to put them together. Okay, so it's good to recognize that, yes. If we had different bases, we'd be really stuck. But if they're all the same base, all right, we can put them all together there, that's right. So, well, how can we put these together? If we're adding 2 logarithms, that is the same as doing what in a single logarithm? Multiplying, right. So this is really the same thing as natural log of x minus 2 times 2x minus 3. And again, that's kind of like all in that natural log there. And this 2, what do you think we should do that 2 coefficient there? Yeah, probably bring it up as an exponent now, okay? Like we wanted to earlier there. Or maybe, I think, yeah, we said earlier there. Okay, yes, make it an exponent. So now we have a single logarithm on the left-hand side, a single logarithm on the right-hand side, and we can now eliminate those logarithms, right, by using what base? E, right? So we'll do e to the natural log of that stuff, and then e to the natural log of that stuff. E to the left-hand side, e to the right-hand side. Okay, and so we'll be left with just x minus 2 times 2x minus 3 equals x squared. Okay. And then how should we solve from here? What should we do? How should we solve from here? Okay, combine, like what do you mean by combine? Yeah, we got distribute, multiply it out. I see what you're saying. Combine these 2 is what you were saying, yeah, Ro? So yeah, exactly right. Multiply them out. So we get what? 2x squared minus 4x, but minus 3x or minus 7x, and then plus 6 equals x squared. Right? And then at this point now what do we do? To solve a quadratic, it needs to be equal to what? 0. So, Grant, what should we do then? Subtract what from both sides?
X squared.
Yeah, get the x squared. So we have x squared minus 7x plus 6 equals 0. Does it factor?
Yes.
Yeah. Factors to what? Yeah, minus 6 minus 1. So, x equals 6, x equals 1. So 6 and 1 are our solutions, right?
No.
Well, right. Now let's check those extraneous solutions. So I put in 6 into the first thing. 6 minus 2 is 4. Natural log of 4 is what we got there. 2 times 6 is 12. Minus 3 is going to be 9. So I have natural log of 6 plus natural log. Maybe I should just show this here rather than. So again, this will be natural log of 4 then plus the natural log of 12 minus 3 is 9. right? Okay, yes, sorry, just check my math. And then 2 times the natural log of 6. Okay, are these going to be the same thing? Well, if I have natural log of 4 plus natural log of 9, that's the same thing as the natural log of what? 36, right? Because again, you have addition there, so addition becomes multiplication. So it's multiplied, 4 and 9. 2 natural log of 6. What's that going to really be? 36 as well, right? Because the 2 can become the exponent of the 6 there, so it's 36. And so we get it. Natural log of 36 equals natural log of 36. Check, it works. All right, let's try 1. 1 minus 2 is negative 1. Natural log of negative 1. Not possible, right? So we have to throw out that one. All right. Same thing for the natural log of 2x minus 3 as well, right? That would also be negative. No bueno. Okay. All right. Let's try another one here together, and then I'll have you guys try one on your own. All right. Log of z minus 3 equals 2. Okay. Log of z minus 3 equals 2. We don't have multiple logs here that we have to worry about combining, so we just have regular old log. Okay. Log is log base 10. So what do we do here to simplify things? Yep, we're doing exponential. And our base for our exponential is going to be what? 10. So 10 to the left-hand side, 10 to the right-hand side. Those are going to cancel out. We're left with z minus 3 equals 100. So z is 103. And then, of course, you can plug it back in and check it, right? 103 minus 3 is 100. Log of 100 is 2. 2 equals 2. Check, check, check. All right. So here, let me give you guys one to try. Log base 4 of x minus log base 4 of x plus 1. And let's say it's equal to 1/2. Hello, Jeff. Bless you. And actually, I think this, you can keep that for your parents. That's that one. Thank you. All right, so go ahead and try that last one there, okay? Try that last one. I think that's a 1/2. Yes, exactly. Do 4 to the left-hand side, yeah, 4 to the right-hand side. So yeah, put them together first, but now a subtraction between the two logarithms. So combine the logarithms together first. Combine the two logs together first. If you have a log minus a log, that becomes what inside of a single logarithm? Well, would it be multiplication? And then subtraction, what are we supposed to do? Divide, right? It's supposed to be division. So then, yes, put them together with division. Simplify. Jen?
I feel like this is so easy. So
What's that? Oh, right. Well, what's 4 to the 1/2? Let's simplify the right-hand side first. 2. So then you have x over x plus 1. So the problem is you have x in the numerator and x in the denominator. So can you get the x out of the denominator? If so, what do you do? Get it out of the yeah, multiple x by x plus 1. Continue solve. Now that they're all out of the denominators, you can combine like terms or get them to one side, and solve for it. ugly.
But like, what was that first?
All right, so you have a few people still working here. Like 30 more seconds or so. I'm gonna clean up this ant-infested thing. Piece of granola bar.
People always forget that for like chemicals and all stuff, and that's not. It really isn't. It's fall's going on for 2 more months, buddy. Like not until December 21st, but you know. Fall is my favorite season, and it's gonna last as long as I want it to last.
All right. So, do we have an answer here? Someone want to volunteer? -2? No solution?
I got -2.
-2? Did you check your -2 back in the original problem? No. Right, so if you said -2, that does give you the x, but the problem is when you try and plug -2 back in to solve the equation, it's extraneous, right? Or not extraneous. The -2, it turns out to be extraneous because -2, you can't take the log base 4 of -2. It's not in our domain. It's restricted from our domain. Okay? So let's go ahead and solve this, though, just to see it, right? So when we have multiple logarithms here, so we're going to combine them together. Since it's subtraction, we'll change that to what operation? Division. So we have x over x plus 1, and that's equal to 1/2. Okay, we have a single logarithm, so now we can use either the, convert to exponential form, or we can just go ahead and just do 4 to the left-hand side, right? 4 to the right-hand side. And so that'll leave us with the x over x plus 1 equals 4 to the 1/2. What is 4 to the 1/2? 2. Okay, at this point, right, we got to get that pesky x plus 1 out of the denominator, so we'll multiply both sides by x plus 1. So we're left with x equals 2x plus 2. Right? Subtract the x over, subtract the 2 over. So we have -2 equals x. Okay? But, right, when we check it back in, log base 4 of -2 doesn't exist. And so their answer is there is no answer. Okay? Questions on any of that? If you wanted to use that whole idea of graphing things on your graphing calculator, remember that I said that any equation that you ever run across, you can solve by graphing the left-hand side, graphing the right-hand side, find that point of intersection. Okay? If you're going to try and graph this, all right, and if you don't have log base, so if you have log base, it's easy. You just put the 4 in, you put the x in, then you can do minus, log base 4 of x plus 1, et cetera, et cetera. If you don't have that, you have to use the change of base here. So you could say, for example, log of x divided by log of 4, that's equivalent to log base 4 of x minus log of x plus 1 divided by log of 4. Okay, and then I'll graph the 0.5 and the other y2 there, we'll say. Let me do zoom 4. All right, so there's our left-hand side. Okay, and there's 1/2. Okay, and you can see here, well, maybe it's going to keep going, but if you keep extending that window out, so let's see here, I'll go x max a lot. X max a lot. And it'll take a little while to graph. You can't even see it now, but and there's the 1/2. Maybe we can go to our table and see here what happens. So let's see. Maybe that'll be a better idea. So I'll type in a really big x value there, and you can see that for our y1 curve, which is the left-hand side there, -7.1 e -11. So what are we really getting really close to here? We're getting really close to what value? So -7.1 and then e -11. Remember, when you see that, some of you guys saw that in your population project. What does that e -11 mean? Yeah, it's times 10 to the negative 11th. So this is like point 0, or it's negative 0.0000000000071. So this is really close to 0, right? It's really close to 0 on the negative side there. Okay, so it looks like we have a horizontal asymptote in this case of 0. It looks like we might. Let's see if I type in a bunch more zeros and I can break the calculator. Oh, it just says 0. It gives up. You're no fun, calculator. All right, well, anyway, at least it didn't break. So that's it. That's all I got for you. So what we're going to do then for the remaining time in class, you've got a worksheet for some practice with these. Okay, so worksheet with practice on Google Classroom, or you can do your population project. Okay, if you still need help writing your curve of best fit, let me know and I can help you with that. Okay? Yes, absolutely. Yes, yes, yes. Thank you for reminding me.
Can I see your table from
Mr. Mark, can I take my quiz now?
Yeah, if you're ready, Maddie G.
Yeah.